button. Okay, so there's 3 tests that we have so far, right? We have nth term, we have geometric, and we have integral tests, okay? And the hardest part about the test, it isn't doing the test itself unless it's integral test, right? It's which one do you start with, okay? That's the hard part, okay? It's where do we start this thing? So anytime I see, even if there's extra stuff with it, anytime I see an n and an exponent, I'm going to use geometric series, right? So n in exponent, use geometric series test, okay? And I cannot change this. This looks really bad to me, but this is the only way Otis will do that notation, okay? It really should have the n equals 1 in the bottom and the infinity symbol on top. Even though that's the way I type it in, it looks that way when in the structure type, but it does not pop out that way. So I'm sorry about that. All right. I am going to separate this a little bit, okay? Whenever I see this, it's very similar to, and I know we talked about it when we were doing the notes. It's similar to that e to the whatever thing we do when we do separation of variables, and we got to undo what we've done before with the exponents. So that's another way to say 3 to the first times 3 to the n. I reversed the order of it, okay? Because remember, when we are multiplying, we have the same base. What are we supposed to do with the exponents? Add. All I did was undo that, right? That's the one thing in algebra that drives me bananas. We never teach you how to undo it. All right. I'm now going to focus in on this part here. I'm trying to create my ratio, okay? Because that's what I need for geometric. All right. So sum is n equals 1 to infinity. I've got 3. And I'm going to rewrite this as 3 over 2 to the n power, right? Because they're both to the n power. So I can take that n power and basically factor it out, kind of. It's not what it's really called, but that's what we're doing. Okay. That's my r right there now, right? So my r is equal to 3/2. So is that less than 1 or greater than 1? Greater than 1. Okay. So in geometric, and you have to know which one is greater than 1 and which one is less than 1 for the quiz. And you're going to have to actually know that information. So if it's greater than 1, does it converge or diverge? That's a diverges. Okay. So there's only 3 you have to make sure you understand how to do really well. I want you to make sure that you understand if the ratio is greater than 1 or less than 1, what happens. Okay. So that one should have been diverges. Okay. Good on the first one there. We should actually, when we see a geometric one, we should be like really thankful because geometric ones aren't so bad because it's just looking at the ratio, it's just finding that ratio. Okay. Here comes the next one. This one, believe it or not, is not the one that we need to get rid of. Okay. Though I was contemplating it for a while, but I figured it out. Okay. This one came straight out of AP Classroom. All right. It's not impossible. We have to use. So I found the problem in AP Classroom this morning, and then I'm like, once I saw it, I'm like, oh, duh. Let me just preview for you. Okay, we'll do the whole thing. Isn't this, if I circle that right there, think about taking an integral of that now. If I was going to take an integral of that, what would you use for your u? You'd use natural log of n. What's the derivative of natural log of n? Isn't it u substitution for our integral? All right. I didn't see it either, you guys, when I was looking at it, okay? So I totally blew it, okay, when I started looking at it. And I went in and looked it up. Once I saw that, I'm like, oh, that was really stupid, right? Okay, so let's prove that we have to do the integral test on it. Okay, so there's 3 things we have to show for integral test. What are they? Positive, continuous, and decreasing. Okay, so we need those 3 things. So I want you, for my test, you're going to show them to me, okay? There will be no more than 1 integral test on the quiz, okay? So there's probably like 4-ish questions. I don't know. I'll look when we're done, okay? 4-ish questions. There'll only be 1 integral test, okay? Because as long as you can show me this once, I'm happy, okay? So Positive means I just got to make sure I plug my terms in. What number am I starting with? 2. Okay, so 2 natural log of 2 plus 1 over 3 natural log of 3 plus 1 over 4 natural log of 4, ... They look pretty positive to me, right? So this is how we're proving positive. Okay, so in our heads, we know, yeah, there's no way that's going to be negative. All right, continuous, it's continuous as long as our denominator is not equal to what number? 0. Okay, so I'm going to take my denominator and I'm going to set it equal to 0. Okay, that looks like 0 product property to me, right? Okay, so I would split that up into n equals 0 and natural log of n equals 0. So I know this is okay because the interval's from 2 to infinity. So I know that that's fine. We don't have to worry about that one. Here I would probably do the e thing, right? E to the natural log of n equals e to the... It's been a while, right? So that means n equal to 1. Is that in the interval? No, it's not. So now do we understand why it starts at 2? Because if it didn't start at 2, it wouldn't be continuous. Okay, so therefore continuous. Okay. Now we have to do the ugly part, which is the derivative, right? That's how we prove decreasing, is we prove it by taking the first derivative and seeing what interval would make it negative, okay? Now, it's up to you. If you leave it in n's, I'm okay with you leaving it in n's. We really probably should convert it to x's, but I'm just going to stick with n's because that's what I showed you, okay? So we're going to go f of n equals, it's this, I chose to, because we're doing derivative on it, to take this and bring it upstairs. And there's probably more than one way to do this, and bring it upstairs as a negative exponent versus doing a quotient rule on it. Okay, so I decided to go with product and chain versus quotient and product. Okay, your choice. N natural log of n to the negative 1 power. Okay, so I'm taking the derivative. I'm going to do it's the chain rule first, right, according to the way I did it. So this thing would be the inside function. The negative 1 is the outside. So negative 1 and leave the inside alone. What would my new exponent be? Good. Now I've got to do a product rule inside the chain, the inner function, right? Okay. What's the derivative of n? 1. It's like the derivative of x, right? Let's scroll that up for you. All right, and then I'm keeping the natural log of n the way it is. What operation in between? Plus, good. All right, keep the n the way it is. What's the derivative of natural log of n? 1 over n. Perfect. Okay. So let's see if we can simplify that a little bit. This piece here would be negative 1 over, I'm going to write it a little lower, sorry. That's the copy and paste and the the print screen thing getting in the way. Screenshots, that's what they're called. All right, and then this here would be, actually it could go in my numerator too, couldn't it? Natural log of n plus 1, right? Because that would just cancel to 1. Okay, so what I'm forcing this to do is I want to force it to be, I want to know where it is decreasing. So I need to force it to be less than what? Yep, I need to force it to be less than or equal to 0. The nice thing is it never matters how ugly our denominator is, because what happens? It's going to cancel with a 0, right? 0 times that denominator to get it moved to the other side is going to be 0. Okay. So I've got negative 1 natural log of n plus 1 less than or equal to 0. How do I get the negative 1 to the other side? Divide. Okay. What's that going to do to the inequality sign? Flip it. And my more advanced math brain wouldn't distribute, right? It would divide over. If you want to distribute, that's fine. Okay, but I always would have, I'd rather just divide over than distribute if I can. All right, how do I move the 1? Subtract. Natural log of n is greater than or equal to negative 1. I totally made an arithmetic mistake when I did this earlier. Okay. All right, how do we get rid of the e? Oh, sorry, the natural log. With e, right? Okay, so e to the natural log of n greater than or equal to e to the negative 1. So n is decreasing when we are greater than or equal to 1 over e, which makes more sense than what I got earlier. This is 1 divided by 2.718, right? Is our interval started at 2. Would 2 fall in that in what we just got? Yeah, because this is like 0 point something, right? So we know it's decreasing when it's 0 point something bigger. Okay, so we know that works. Okay, so we know that we've got it. We can apply the integral test, that's probably almost the proving it, especially that derivative, is probably worse than actually doing the integral test. Okay, so now let's do the integral test. I'm going to try to find myself some space to write it. When I print a screen, look at this. It gives me both screens that I've got going. Isn't that great? It's not. All right. So I'm going to put my integral test over here. So first of all, on the AP test, you would state f of n is positive, continuous, and decreasing. Okay. You can just say that. Okay. If I had extra time, right, I've got tons of extra time, maybe I would go through and do this to prove it. But on the AP, I want you to prove it for me. Okay. Because I want to make sure you understand that. But the AP test, that's where you start the FRQ if it's an FRQ. Okay. All right. We now we're going to switch to our improper integral, right? So we're going to find the limit. Actually, we write our summation as 2 to infinity, 1 over, really let's switch it to x's. I'm going to switch it to x's. It really should be in x's when we're integrating. Natural log of x dx. So we know that we switch that because it's an improper integral with limit as n approaches, not n, b approaches infinity of 2 to b 1 over, and I'm going to rewrite this a little different, 1 over x times 1 over natural log of x dx. Okay. Remember, the first thing we always try when we're integrating, if it's not a basic integral, is use substitution. I totally forgot that rule when I was looking at this problem. Okay. So what's the u? We kind of already hinted at it. Natural log of x. Okay, so that means that du is 1 over x dx, which, handy, I've got that there. They were trying to be nice. I just didn't see it. Okay, so I'm substituting in. I just have 1. Oops, it's 1 over u. Where's my blue? 1 over u, right? Du is what I have to integrate. Sorry, it's kind of skinny. I got it all skinny right now. All right, so when I integrate 1 over u, what do we get? Good. So natural log absolute value of u. You guys are really good at that. AB is not quite there yet. They're getting close. We did u substitution this week. Kind of done with u substitution. I like our shortcuts when with u substitution. I'm tired of doing it the long way this week. All right. I'm putting in the b and the 2. So limit as b approaches infinity, natural log absolute value of b minus natural log absolute value of 2. And I know it always seems weird to me in my head that why do we plug a b in and then plug the infinity in? It seems silly, right? It's the proper way to do it. If this was an FRQ, you would have to show it that way. Okay. All right, I'm plugging in the infinity. So I have natural log absolute value of infinity minus natural log. I guess I could just write 2. If you want to write the absolute values, that's fine. What does that equal to? Yeah, what's wrong? Natural log of, say that again. You just plugged in a b for the u, but the u is natural log of that. Right? Yes, you're right. I should have had an extra thing in there. I totally went I missed a line. Let's fix it. I'm going to fix it in here. Okay, so I forgot. I didn't finish my U substitution. Natural log of x from b to 2. Ooh, why am I doing a fraction? B to 2. And then this would make it, I need a natural log of b in here, right? And I need a natural log of 2 in there. I'm really squishing it in. And another natural log on this thing here, right? Wouldn't matter. I'm going to get the same answer either way, right? Though it should matter. Okay. What am I going to get as my answer? It's going to be infinity. Okay. So does that mean that it converges or diverges? It diverges. Okay. If it's anything but infinity, right? It converges. If it's infinity, it diverges. Yeah. It was decreasing because we forced it over here. We said, okay, we know that that's the derivative. We know when the first derivative is less than 0, it would decrease, right? So we forced it to decrease. So this is the interval of decrease. And we know that, or decreasing, right? We know that our particular function, our interval was from 2 to infinity, right? And this is definitely 2 to infinity is greater than that number. Go ahead. Does that make sense, Cynthia? Yeah. Okay. Good question. Those are like little weird nuances that we need to make sure we understand. You guys, this part over here is probably more for the college. You go in and take in the college class, right? Than for the AP test. Okay. So I don't want to leave you hanging there either. Okay. All right. Yep, I'll go back that way. Sorry. Okay. You let me know when you guys are ready. I'll give you another minute or two to get that cleaned up. Okay, you ready? Okay, so my husband just texted me. Well, that was all going on, right? And this is the text I just got. He just told me he just noticed that this is the date at the end of the year. This year. It's 1, 2, 3, 1, 2, 3. Isn't that romantic? He taught AP Chem when he taught, so you can only imagine what happens at our house. All right. This is the one that we're going to get rid of. So for the life of me, I couldn't figure out why I put it in here. There's another test we have later on called the ratio test that it's perfect for, but it doesn't seem to work by any of the ones we have. When I went back and I looked in the notes, I think I was trying to use nth term on it, and it was in the notes we had found one that was inconclusive, okay, with nth term tests. And that wasn't one of our options. Our options were converges or diverges, right? So we're going to just get rid of that one. All I could get was that it was equal to 0 because the top, the top didn't grow as fast as the bottom. Exponential is going to win over factorial. Okay. So it was just, everything I tried wasn't making it work. So, and then when I went and I photomathed it, which for my own sanity, it was coming out as a ratio test. So we won't see that one on the quiz. I'll make sure it's not there. Okay. All right. So, rule of thumb on this one. What do we notice in the problem? We have an n power, right? No matter where the n power is, numerator, denominator, we're going to try to manipulate that to be which test? Geometric. Okay. So we're going to try for a geometric here. Okay. And again, I'm going to try to manipulate the algebra that's there to get it to fit what I need it to fit to use a geometric on it. So a geometric means I need to find a ratio that's something to the n power. Okay, so I'm going to separate this. So n equals 1 to infinity. I'm going to bring the 3 out. So that's going to leave what number in this numerator? 1. Good. Thank you for getting the door. All right. Technically, couldn't I write it as 1 to the n? It's the same as 1, isn't it? Have I now created that n power that I'm looking for? In both my numerator and my denominator, when I do that, I now have my ratio. Okay, so you got to learn to get good at manipulating the ratio. Okay, so there's my r. Is it greater than 1 or less than 1? Less than 1. So does that mean it converges or diverges? Converges. Okay. So it's not going to be like a straight obvious ratio. You're going to have to manipulate. I want to see you make sure you understand that you might have to manipulate that to make it look like a geometric. Okay. Because if I just gave you this, right, if I gave it to you, it would be way too easy of a problem, right? If I gave it to you in that form. Okay. All right. Let's take a look at the next one. Did I go too fast? Okay, sorry. I'll wait. We good now? Okay. All right. Now, this one, we see the 2 to the n. So what's the first thing you think? Geometric. Okay. But there's no way I'm going to get this to be to the n power, right? And I can't like break that off to the side or do anything else like that with it. Okay, so geometric's probably not going to work on this one. I'm going to avoid the integral test at all costs if I can, right? Because it's long and hard. So I'm going to try nth term. What was the key to doing nth term? How do we start it? Yep, limit as n approaches infinity. And a lot of the tests beyond the 3 that we know use this limit as n approaches infinity. So much so that you won't even recognize my little limit because I write it so many times. Okay. All right. The poor kids in AB, because I write it so many times in here, they hardly know what that actually means. All right. So now we're looking at growth, right? Which one is growing faster? Which one is, so we're looking at which number is bigger versus which number is going to be smaller, okay? So which one's going to get bigger faster, the numerator or the denominator? Numerator. Exponential wins over an exponent of 1, right? So we know that this one's going to be bigger. Okay. So if the numerator is bigger than the denominator, as I approach infinity, what number am I going to get? You're going to get infinity, right? The biggest number I can, okay? So nth term test was a comparison to 0. Does it equal 0? No. So if it doesn't equal 0, that's the one we're looking for. An nth term test only has one answer. What's the one answer we can get off of nth term? Diverges. If it doesn't diverge, you picked the wrong test. Well, it's inconclusive. You didn't pick the wrong test. You got to try something else. Okay? Yeah.
So how do we know when to use nth term
versus integral test? So if my nth term test came out, if I tried nth term, because that's exactly what I did on this one up here, the one with the natural logs in it. I went nth term first, right? And I got, so if I do nth term limit as n approaches infinity of 1 over n natural log of n, that's definitely 1, it's definitely 0, right? It's exactly equal to 0. So that means that nth term is inconclusive. I have no choice. I have to go to integral. Does that make sense? Okay. Again, we're only like 2 weeks into this. You're going to keep getting better at it. Okay. This is kind of our first stab at this. All right. So let's look at this next one here. This is actually a very straightforward, should be an easy one. Okay. Which test? Why geometric? The exponent has an n. Okay. Now, I could manipulate this a little bit to make it look like not an n minus 1, right? Because it's really just supposed to be to the n to figure out the r, though you can probably guess what the r is right now. I could break it off into the 2 over pi to the n and 2 over pi to the negative 1. I only move this one up front because we like the number in front, right? Which if I really wanted to, I could flip those around and get rid of the negative 1 on it. It doesn't matter because isn't the ratio sitting right there? Okay, so our ratio is 2 over pi. If I give you one that's straightforward, I'm going to give you a weird ratio, right? The favorite is like e over pi or pi over e, right? Doing something crazy like that. What's technically, what's the denominator approximately? Yeah, it's 3 point something. So that's really your, that's about what your what the function looks like, or your r looks like, right? Is that bigger than 1 or less than 1? Less than 1. So if I am less than 1 on a geometric, do I converge or diverge? Converges. Okay. I really want you to make sure you get down to less than 1, greater than 1, because there's another test we do that same thing on, but it's opposite. Okay, so you need to make sure you got geometric down. Okay, before I don't even want to teach that other test until you have this down. Okay, everybody got it? Okay. All right, I think, is this the last one? Yeah, okay. So on this one right here, okay, can it be geometric? No, right? It can't be. Our exponent isn't the n, right? And it's really obvious, especially in that numerator, it's not the n. So we know we can't use geometric, okay? If I did nth term, okay, I would have to do a bunch of L'Hopital's rules, right? But which one of those is winning? The numerator or the denominator? Which one's the winner of the size? Denominator wins, right? That's bigger. So if my denominator is bigger and I took the limit as we approached infinity, we would get 0. So what does that mean about nth term? Inconclusive. So now I'm stuck. I have to do the integral test. Okay. So we're practicing one more integral test for you. Okay. Which is not a bad thing. All right. So let's put in our, I'm going to expand it. I'm going to write it off here. I'm going to erase that mess. Okay. So positive is first, right? So let's see, I'd have to have, I'm not going to try to multiply it out. 2 to the 4th, e 2 to the 5th, plus 2 to the 5th. Sorry, not 2. What's my other next number would be 3, right? 3 to the 4th over e to the 3 to the 5th. This is looking pretty positive, right? As long as you've gave me 3 terms, I'm happy. Okay, definitely positive. Okay, how do I prove continuous? Set the denominator equal to 0, see what makes it where the vertical asymptote is, if it exists, right? All right, so e to the n to the 5th equals 0. How do I get rid of e? Natural log. So I would go natural log of e n to the 5th equals natural log of 0. That goes away, but what's the natural log of 0? It's not. It's undefined. Yeah, so I think we're probably pretty safe, okay? This is something that's kind of an inconclusive statement. There isn't an interval where it's a continuous function, okay? So therefore continuous. If it comes out goofy like that, it's typically you're fine, okay? All right, last thing we got to prove is what? Decreasing. How do I do that? Got to take the derivative. What am I going to need to do to take the derivative? Quotient rule. What's hiding in the quotient rule? A chain rule. Yay. Okay. We've been practicing all those things lately too, haven't we? All right, so we're going to call it f of f prime of n equals, we're being lazy and leaving it in n's. All right, so 4n, right? And then I keep this green mess the way it is, e to the n to the 5th. What operation in between? 4n cubed, thank you. Subtraction in between, and then I'm keeping the n to the 4th. All right. Chain rule. I keep the E thing exactly the way it looks, right? And I do the derivative of the inside. What's the derivative of the inside? 5n to the fourth. That was convenient. All right, that they're both the same exponent. All right, and then I got to do my denominator squared, which honestly I'm not even going to worry about multiplying out, right? Because it's going to go away in the work we have to do in a second anyways. Okay, I need to force this to be less than or equal to what? There, and notice I'm not bothering simplifying. I will do the simplifying as I'm doing the next step because I'm trying to write out less work. Because I do not care if this simplifies because when I multiply it to the other side, what happens? It's canceled, 0, right? Okay, at the same time I'm multiplying that over, maybe I'll do some work over here. So let's see, it looks like I have 4n cubed. There's nothing else I can really do with this first term. Here, I could put my n's together, right? So that would be minus 5n to the 8th e to the n to the 5th equals 0. Oh, sorry, no, less than 0. Ooh, less than or equal to 0. Okay. Weird and ugly. What do you think we got to do? Greatest common factor. Okay. So what is the greatest common factor? Yep. And then we left with 4 minus 5n to the 4th less than or equal to 0. And then technically, what property do I need to use? Zero product. What are we going to get off of this mess here? Probably going to be 0, right? So I'm going to use that. Technically, we could go all 3 of them separate, couldn't we? I guess if we really wanted to. 4 minus 5. Yeah. 5 and 2. Did I subtract wrong? Yeah, that's okay. That happens. I made a mistake in my head. There we go. Okay. So this is still going to be n less than or equal to 0 is where it would be decreasing. This one would be what we would take the natural. This one would be inconclusive again, right? We'd get that natural log of 0 again. So that's kind of a waste of time. All right, negative 5n to the 5th less than or equal to negative 4. I got to divide that over, so it's going to be positive 4/5, but I flipped the inequality sign. So I know it's decreasing when it's less than 0 and when it's greater than 4/5. I'll let you catch up, and then we'll talk about if that's in our interval. Okay. Where did we start? 2. Oh, that wasn't supposed to cross that out. It was supposed to highlight it. All right. So are we in the right interval? Is it in a decreasing interval? Yes. So we know it's decreasing. Okay. Therefore, decreasing. Okay. So let's go over to, we still haven't done our integral test. We still got to do that part. Okay. So I'm kind of trying to get it over here so I can see both at the same time. All right. So I know I've got to integrate from 2 to infinity. I'm going to switch it to x's. X to the 4th over e x to the 5th. Ooh, I see a u substitution again. Look at that. I had the seating chart up this time. All right. So I have to start the limit as n approaches. B approaches infinity, not n. 2 to the b of x over e x to the 4th over e x to the 5th dx. Okay. What's the u? I would just use x to the 5th, right? Because I don't have another e sitting there. Yeah. So x to the 5th. I'm going to go with the dark blue. Oh, that's the same color I'm using. Let's use purple. Du equals what? 5x to the fourth dx, right? All right, so we know we put up what on the inside? 5, and on the outside? Okay. I am going to show the u sub this time because it's a little bit uglier. So limit as b approaches infinity of 1/5. We've got e to the u, which is a little bit weird. And then we've got the 1 du on the inside, right? And we're still to this, technically 2 to b, but we're going to put our u back in. All right. I can't integrate that the way it looks. What am I going to have to do first? Move it up, right? That's going to be weird though, isn't it? All right, we'll try it. Limit as b approaches. I didn't go look up an answer for this one, and I didn't try it this morning, so it's a surprise to me as it is to you right now. E to the negative u du. Oh, I guess we just have another u sub in there, huh? Let me write it a little neater. Okay. Oh, how did I get a 5? My goodness. See how easy it is to mess it up? Okay, if I was going to do the little u sub on this part, what would I get out of it? It's just going to be a negative, right? So can I just put a negative on the inside and the outside? Yeah, let's just deal with that. And then we're just going to ignore the one that's on the inside, right? All right, so you've got the limit as b approaches infinity, negative 1/5. When I integrate e to the negative u, what do I get? E to the negative u. I'm going from 2 to b, and I need to substitute my u back in, right? The one that we had originally. I'll let you catch up. So catch up. Still doing really good on time. Okay, I'm going to move this back downstairs, and then I'm going to sub my u back in, and then we'll do the b thing, okay? So limit as b approaches infinity of negative 1/5, 1 over e. At the same time I'm moving it down, I'm going to go ahead and bring this in, because you guys are way more sophisticated than my other group right now. It's driving me crazy that I have to write the u 5 million times with them. I know they'll get to where you're at someday. Okay. I'm going to plug in the b and I'm going to plug in the 2, right? So we've got the limit as b approaches infinity of negative 1 over 5e to the b to the 5th minus negative 1 over 5e to the 2 to the 5th. Okay. We're going to put in our infinity, right? So negative 1 over 5e to the infinity to the 5th plus 1 over 5e to the 2 to the 5th. Those almost look like the same thing. I can't even read my own hand. That's an infinity symbol, right? Okay, there we go. All right, technically this is infinity in the denominator, so what's this term become? 0 plus whatever this garbage is back here, right? So did we get infinity? No, that's all we care about. We don't care what this number is, right? We didn't get infinity. So does it converge or diverge? Converges. So you've had one example of integral test where it converged and one where it diverged. I'm not putting both on the quiz, okay? So it'll be one or the other. All right? That's it. Please make sure you study, okay? If you need more problems, there's this nifty thing called homework that I gave you. It has more problems on it.